Find each limit. Part A, the limit as x approaches 2 of x cubed minus x plus 3. The function x cubed minus x plus 3 is a polynomial. So that means that the limit as x approaches 2 is just going to be the function value at 2, or f of 2. So to compute this limit of this polynomial, we just need to substitute x equals 2 in for x everywhere in f of x. And we get the following when we substitute x equals 2 into the function, and I'll type this into your calculator, and we get 9. And just to note, this value is equal to f of 2. Part B, the limit as x approaches negative 1 of x cubed plus 4x times 2x squared minus 3x. So notice that we have the limit as x approaches negative 1 of two functions that are being multiplied. So that means that we can use our product property. And that means that we can find the limit of the first function and multiply that by the limit of the second function. So we get the following when we use the product property of limits. Now let's go ahead and find the first limit. For the first limit, we have the function is x cubed plus 4x. And this is a polynomial, so that means that in order to find the limit, we can just substitute negative 1, and that's going to be our limit value. We can also do the same for the second function. This is a polynomial, so in order to compute the limit at negative 1, we can just substitute negative 1 in for x, and that value will be the limit value. So now let's substitute negative 1. Whenever you are substituting values into a function, especially with negative values, it's important to put parentheses around the value that you are substituting. So I put parentheses around negative 1. I have this expression here, and I'm going to multiply this entire expression by something else. So I'm going to go ahead and enclose this expression with square brackets, and we use square brackets the same way we use parentheses. Now let's substitute negative 1 in for x for the second expression. So we have the second expression in square brackets, and we substituted negative 1 in for x, and notice that we put parentheses around negative 1 everywhere we substituted it for x. When you type this expression into your calculator, treat the square brackets just like parentheses. We get negative 5 for the first value, and 5 for the second value, so we get negative 25. So the limit as x approaches negative 1 of f of x is negative 25. Part C, the limit as x approaches 9 of the square root of 4x minus 11. If you look at the properties of limits, we actually don't have any rules for a square root. However, one thing that you must remember is that a square root is equal to a half power. So we can rewrite the square root of 4x minus 11 as 4x minus 11 to the half power. So because we rewrote the square root as a half power, we can now use the power property of limits. So that means we can take the limit as x approaches 9 of 4x minus 11 and take that entire expression to the half power. First, let's compute the limit as x approaches 9 of 4x minus 11. 4x minus 11 is a polynomial, so that means that in order to find the limit as x approaches 9, we can just substitute x equals 9 for x. So now let's substitute. We get the following, and 4 times 9 minus 11 is 25. And we get 25 to the half power. You can input 25 to the half power in your calculator, or you can convert the half power back into a square root. So we get the square root of 25, which is 5. So the limit as x approaches 9 of the function is 5.